So what we've seen so far, that at longer wavelength region, always remember, because your questions in exam generally asked for this long wavelength region only. Okay, because the problem only can be simplified when you have a k tends to 0. So it's easy to make question on longer wavelength region compared to making questions on short wavelength region. Okay, so you should know what is your short wavelength or high wavelength. Okay, so now let it be solved for short wavelength region. Okay, so put the heading now. हाँ बोलिए.
So you said that this long wavelength region is important for our exam, no? Mainly.
Yes. This long wavelength region is very important for exam, because your omega versus k relations that gets overly simplified when you put the limit k tends to 0. Okay, if k tends to high frequency, k is not low, then simplifying dispersion relation is very difficult. Okay, so let us solve one problem, then you understand okay what I'm saying. So just one question came in exam. Okay, so we are given, so this we have solved for 1D lattice, but we can generalize for 3D lattice. Okay, so one question came in exam. Okay, say for a 3D monoatomic crystal. Okay, calculate VG, group velocity. Okay, you need to calculate the group velocity. Okay, at long wavelength region, long wavelength region का मतलब है k tends to 0, and they have given you the omega relation. We know the omega, what is omega m omega square. Okay, we know what is m omega square, or m omega square is equal to what, कितना होता है
4 beta by m sin k.
That is a one dimension. Okay, if generally the relation is what, cos 2 bit cos, यहाँ पे क्या है 1 minus k.
K.
Okay,
yes.
now for 3D, now it is 3D crystal, so we can write like this: 1 minus, okay, cos kx by a minus cos ky by a and minus cos kz a. Okay, so this is the expression is given, and they are saying calculate the group velocity at long wavelength region. Now this kind of expression only can be simplified when we have k tends to 0 limit. Okay, so if I now want to calculate the group velocity. Okay, so for k tends to 0, okay, I can write cos kx as equal to cos x is equal to 1 minus x square by 2. Okay, if x is very small, so similarly I can write here cos kx equal to 1 minus kx square a square by 2. Okay, similarly I can write cos ky a equal to 1 minus ky square a square by 2, cos kz a 1 minus kz square a square by 2. Okay, if this limit is not there, you cannot write like this. So now limit is there, you can put the values here, put these values here, and calculate the group velocity. Group velocity is nothing. Group velocity is simply Vg equals to d omega by dk. Calculate. I hope this question is clear to you, na? So they have given one dispersion relation for 3D crystal. They have just generalized what we got for 1D. Okay, 1D we got 1 minus cos k. In 3D, they make 1 to 3 and they have generalized this expression for 3D. Okay. Now for this expression, they are asking what is the group velocity at k tends to 0 region. Okay. So in k tends to 0 region, I can simplify these values like this. Okay. And now I can solve.
So root over beta by m into a.
So this I can write omega square 2 beta. Okay. This 3. Okay. 3. You can put minus 1 minus kx square a square by 2 minus 1 minus ky square a square by 2 minus 1 minus k z square a square by 2. Okay. So if we solve this one, okay, so 3 cancel. So if you solve this one, this will come you m omega square 2 beta. So this will become plus, this become plus. So you got kx square ky square plus kz square into a square by 2. 2 cancel. So you have omega square equal to this become k square. So beta k square a square. Okay. So by m. Okay. So omega will be what? Omega will be simply ka under root beta upon m. Okay. Now if you want group velocity Vg, that will be d omega by dk. Okay. So if you differentiate this one, okay, you would got what? Beta a square by m. Okay. This is the answer. Vg equal to under root beta a square by m. ये आ रहा है ना सबका, बाकी लोगों का भी?
Yes sir.
Okay.
Yes sir.
So generally your dispersion relations, they are easily solvable at long wavelength regions. Not only here, when you go for band theory and other things, okay, there also you'll see this type of questions. They'll give this approximation. Okay. So this was the example of long wavelength region. Just put the heading now for short wavelength region. Okay. Now again put the expression we have omega sine k by 2. Okay. Now there is no limit approximation. Okay. K is not tends to 0. Okay. K can be any value which is not close to 0. K is not close to 0. So for those things you cannot put any approximation here. Okay. So simply you can write what? If you want phase velocity, that will be what? Omega by k. Okay. So I can write this is omega m. Okay. Omega m sine k by 2 upon k. Okay. And so this what I can write, this phase velocity I can write omega m. Here I want k by 2. Okay. So I have to multiply by a by 2. Okay. So Vm a by 2 sine k by 2 upon k a by 2, angle becomes same. Okay. And this v phase velocity you can write, this is what? This is a velocity to sound, v naught. So sine k a by 2 and k a by 2. Okay. So this is your general expression for phase velocity. Okay. So similarly, you can write now for general expression for group velocity also. Write in plot both.
Sir, we want to take limit. For that we have adjusted the angle, or
We are not taking a limit. Okay. I just want to write in this way. Okay. So that it will be easy to plot the graph for me. Okay.
good.
So I am putting a modulus. Okay. That you should remember these are positive values. Okay. So now and you know, okay, this is why V naught. Okay, correct.
Sir,
हाँ
why you have put a K?
बस no, this is equal to, हाँ बोलिए.
सर जैसे आपने V जो हमारा फेज वेलोसिटी इसके लिए ओमेगा बाई K किया.
हाँ
तो सर आपने ओमेगा का वैल्यू एज इट इज रखा, K की जगह K A/2 क्यों डाल दिया? A/2.
A/2 कहाँ डाला मैंने? A/2 लिखा, फिर A/2 से मल्टीप्लाई भी तो किया है, तो कैंसिल हो
ओके
जाएगा.
ओके.
तो कैंसिल हो जाएगा ना.
A/2 ना.
हाँ इस कैंसिल हो जाएगा वो तो. ओमेगा बाई के किया खाली, वो तो इसको
Okay.
इस फॉर्म में लाने के लिए ऐसा लिखा है मैंने.
अच्छा, you have substituted to bring this in this form.
हाँ यस यस, only I have put it, I have multiplied by this k by 2 and divided by, multiplied divided by 2, तो कैंसिल हो जाएगा, वो सेम ही थिंग है ना. Okay.
Yes sir, yes sir.
Okay, so this was your phase velocity. Okay, now write for group velocity. Okay. So I want now group velocity. Okay, group velocity is Vg d omega by dk. Differentiate कर दो. So this would be Vm. Differentiate sin k, you get cos k by 2, and you differentiate k by 2, you get a by 2. Okay, so the Vg will be what? Vg will be simply Vm a by 2 cos k by 2, isn't it? Okay, now plot these graphs. Okay, now plot this graph for k values. Okay, where k goes minus pi by a to plus pi by a के बीच में इसको प्लॉट करना है. Okay, so we have these two expressions. Okay, so if you plot this graph, okay, so if I plot these graphs, okay, for phase velocity for k values from pi by a to minus pi by a, okay, and say this is my middle axis. Okay, so this is my say 1, and I'm plotting Vp upon V naught. Okay, so Vph upon V. So that maximum value can be what? K tends to 0, maximum value can be 1. Okay, and this is sine curve. So how the graph will come? So this graph will come this one, like this.
स्क्रीन नहीं दिख रही है आपकी.
हाँ एक मिनट. दिस इज v फेज वेलोसिटी अपॉन v नॉट. हाँ बोलिए.
Screen
is not working.
What is not working? Video. Okay.
The video is working. Whatever you are explaining, that you can't see.
I don't know what is happening. Just
Share नहीं किया, I think.
let's give you 1 minute. Is it visible now?
No sir.
Okay.
No, sir.
Okay, just give me 1 minute. Now?
Yes, sir.
Okay.
Sir, it's black.
Blur है sir.
हाँ उसको सही कर देता हूँ, एक वो सही हो जाएगा 2 मिनट में. ओके, अभी ठीक है?
No, sir. Sir, blur है अभी भी.
नहीं sir.
ब्लर है अभी भी. बताना सही हो गया नहीं है?
Still blur.
अभी ठीक है?
No, sir.
नहीं अभी भी. Oh, just give me 1 minute.
सर अब ठीक है सर।
Not, हाँ sir.
Yes, but yes, it is.
अभी ठीक है?
Yes,
यस सर।
I hope this is clear.
yes, sir, it's clear.
Thank you. Now I'm plotting the graph. Okay, is phase velocity. Okay, so you can see at k tends to 0. Okay, this is a this Vp by V0 is 1 because this is the highest value. Okay, and then you go beyond, it will decrease. Similarly, if I want to plot a cost curve also, this is also maximum here. Okay, at pi by a, what will happen? Pi k equal to pi by a. This become if you put k equal to pi by a, what will happen? If you put k equal to pi by a, so this angle will become a by 2,
0 sir।
pi by 2. Okay, so if you plot the group velocity, this will become maximum here at 0, and at the boundaries of billion John, these group velocities become 0. So similarly, this curve is for what? This curve is for Vg upon V naught. Okay, so if we plot this curve, okay, what information we are getting? Okay, the information we are getting that at k equal to pi by a, which is nothing, which is the boundaries of first billion John. If I take k equal to pi by a, okay, I am getting my v phonon is finite, is a finite value, while I'm getting my group velocity equals to 0. Okay, now phase velocity is the velocity of phase. Okay, and the group velocity is the velocity of wave packet. Okay, so group velocity is what? So Vg is the velocity of wave packet, or wave packet means is the velocity of energy of wave. Okay, velocity of energy, velocity of energy. Okay, velocity of energy means 0, means no energy is flowing. Okay, so these are called cutoff frequencies. Okay, okay, so that's why at these value no propagation of wave will take place. Okay, so at these values, so you can write, okay, that at this frequency, okay, at this frequency limit, at this frequency, which is when you plot the graph k equal to pi by a minus pi by a. Okay, these graphs are nothing, here is maximum. Okay, so these are the maximum frequency. Okay, so at this frequency limit, at this frequency limit, okay, no signal or energy, no signal or energy, okay, is being propagated, is being propagated. No energy will propagate because group velocity is 0, and the maximum limit we already know. The maximum limit of frequency is what? 4 beta upon m. Okay, this is the maximum frequency limit. Omega equals to under root 4 beta ohm, and this is called your cutoff frequency. This is called your cutoff frequency. Cutoff frequency, इससे ज्यादा की फ्रीक्वेंसी सिस्टम में फ्लो नहीं होगी. ओके, दैट मींस योर लैटिस बिहेव्स लाइक अ लो पास फिल्टर, क्योंकि मैक्सिमम लिमिट है, उसके नीचे की फ्रीक्वेंसी को पास करेगा लैटिस, उसकी मैक्सिमम की मोड सी इसमें प्रोपोगेट होंगे. सो योर लैटिस बिहेव लाइक लो पास फिल्टर. लो पास फिल्टर का मतलब होता है क्योंकि फ्रीक्वेंसी पे अपर लिमिट है. ओके, इसमें maximum frequency, so maximum frequency there's upper limit, only this much frequency can propagate, beyond any frequency will not be propagate. That's why my lattice behave, 1D lattice behave like a, or any lattice, okay, behaves like a low pass filter. Okay, so we have discussed here.
Sir,
Sir, please
Sir,
explain this graph once again.
So I am explaining here. If you plot this graph, okay. So at k is equal to 0, you have k is equal to 0 here. K is equal to 0, you are getting 1. Okay, you use write the expression. Okay, if you've seen the velocity expression, your phase velocity is maximum, your group velocity is maximum, and we have seen in long long wavelength region where k tends to 0, both are same. Okay, actually we should draw like this, little bit should be same. Okay, in long in long wavelength region, my group velocity, okay, group velocity and my phase velocity are same. Okay, as we move towards the boundary, okay, my phase velocity is not 0. Okay, because Vpy this is a finite value, but my group velocity becomes 0 because cos k, if you see the expression for Vg, there is cos k by 2. If you put k equal to pi by a, so that becomes cos pi by 2. Cos pi by 2 is 0. Okay, so this group velocity becomes 0. That means, and the group velocity is the actual velocity of wave. Okay, it is a wave, it is the velocity by which your wave packet moves or your energy travels in the system. So because the now group velocity becomes 0, that means this energy cannot propagate. Okay, so this frequency where your group velocity is 0, that frequency cannot propagate. That means there is a upper limit of frequency at pi by pi. That we already seen. There's an upper limit of frequency. Again, after that, again it will repeat. So this frequency will decrease. This is the maximum frequency, only can up to this much only it can propagate. Okay, so if you write k equal to pi by a, so if you write lambda k equal to pi by a and k equal to 2 equal to 2 pi by lambda, k is 2 pi by lambda, is pi by a, pi cancel, so that will become lambda equal to 2a. So this is the upper limit of wavelength. Okay, upper or cutoff wavelength, shorter, sorry, upper तो ये हो जाएगा, k हो जाएगा ना, k. This is the lower limit of if wavelength is low, energy is high. Okay, so energy is high, that means this is the lower limit of wavelength. इससे छोटी, the any wavelength which is smaller than this one, that cannot propagate in your lattice. That means if you have a lattice, you have a crystal, say this distance a, so the minimum wavelength should be this one. Okay, the minimum wavelength should be this, so lambda equal to 2a. Okay, this should be minimum wavelength. The wavelength is smaller than this one, cannot propagate. Any mode which have a lesser wavelength than this wavelength, that cannot propagate in the crystal. I hope you are understanding what I'm saying. Okay, because you can create any wavelength, na? You're changing k, you're changing k means you're changing wavelength. Okay, you're increasing k. Okay, that means you're reducing wavelengths. So your wavelength can be like this also. Any wavelength bigger than this can propagate, but any wavelength less smaller than this cannot propagate in your crystal. Okay, so you can create many modes in the system. When lattice can vibrate with different frequencies with different wavelengths. There are many modes. Okay, but there is a upper limit. I hope you are getting what I'm saying. Okay.
Yes, sir.
Okay, now this is the one thing. हाँ.
सर इसमें जो फ्रीक्वेंसी हम बाहर से देते हैं वो और जो फ्रीक्वेंसी अंदर में
नहीं, वो रेजोनेंस होना जरूरी नहीं है. ओके, रेजोनेंस अलग चीज होती है. रेजोनेंस में तो मैक्सिमम ऑब्जर्वेशन हो जाता है बस. ठीक है.
नहीं सर, मैं बोलना चाहता कि सर ये जो फ्रीक्वेंसी हम कैलकुलेट कर रहे हैं, शॉर्ट वेवलेंथ, लॉन्ग वेवलेंथ, ये बाहर का
ऑब्वियसली बाहर का फ्रीक्वेंसी पता होना चाहिए ना, बिकॉज़ सॉलिड को किस फ्रीक्वेंसी से तुम वाइब्रेट कर रहे हो.
अच्छा,
ठीक है.
अंदर का फ्रीक्वेंसी हम
अंदर का हम लोग देखते हैं रेजोनेंस कंडीशन आ रही कि नहीं आ रही है. तो रेजोनेंस कंडीशन आती है तो जो बाहर से दे रहे हैं वही अंदर जाता है. ठीक है, वो एक्सपेरिमेंटल पार्ट टेक्नोलॉजी अलग चीज है. ठीक है
सर, ये सब लैटिस के लिए सेम ही होगा.
हाँ, लिमिट तो सब जगह सेम ही होगी। अभी जब हम तो 1D कर रहे हैं, ओके, पर ये लिमिट तो सब जगह लगेगा, 3D में भी लगेगा लिमिट, उनका लिखने का तरीका अलग होगा, बट लिमिट तो रहेगा ही। ओके, 1D में ये सिंप्लीफाई होके आ गया है। मतलब ये इतना तो है ही ना कि ये तो फिक्स है कि एक एक पर्टिकुलर वेवलेंथ से ज्यादा स्मॉलर वेवलेंथ यू कैन नॉट प्रोपेगेट एनी क्रिस्टल। एक मैक्सिमम फ्रीक्वेंसी फॉर एवरी क्रिस्टल देयर इज अ मैक्सिमम फ्रीक्वेंसी, कट ऑफ फ्रीक्वेंसी। और ये तो आपने एक्सपेरिमेंट भी किए होंगे ना लैब, एमएससी लैब्स में, यू मे हैव परफॉर्म्ड एक्सपेरिमेंट, लैटिस वाइब्रेशन किट विल बी देयर। So there, every solid there is a cutoff frequency. Okay, that different. That depends on lattice constant. What is your strength of the material? कितनी what is your K spring constant कितना है material का, Young modulus कितना है? That is also different for different material also. Okay. So now here we have discussed that my K has a, और फिर गया.
सर वीडियो चला है।
हाँ, yes, 1 minute. I don't know why it's not getting. Just give me 1 minute. Okay. So, okay. So now I hope now it is visible.
Yes, sir.
So just now we have discussed this omega versus K relation. Okay. Okay. And I have told you that there's a maximum limit of frequency. Okay. Now what about this K? Okay, these are K axis. Na? K. So whether when we are drawing this K, okay, that doesn't mean this K is continuous. Okay, this K values are also discontinuous. These K values are not continuous. Okay, so when we apply boundary condition, so that is different from continuous, your continuous string. When your continuous string, your K can take any values. Okay, but when you are lattice, this K, this lambda, this wavelengths are not continuous because it's a lattice. Na? You have a lattice. So this is your minimum wavelength. This is a minimum wavelength. Okay, but it can be like this also. It can be somewhat bigger also. Any wavelength can propagate. Are you getting my point? But that is not continuous. You cannot create any wavelength. You cannot create any wavelength, or you cannot propagate any wavelength in the cluster. Okay, so that means your K value cannot be continuous. Your K values are discrete. Okay, and that comes from boundary conditions. Okay, if you apply boundary conditions, okay, boundary conditions, okay, that means now I want to calculate that my K value from 0 to pi by, they are the distinct K values. Okay, but what is their number? K, how many K can be exist between 0 to pi by a? Okay, for given lattice, that is I want to calculate number of modes. Are you getting my point? Each wavelength is a one mode. Okay, each wavelength is related by K. That means each K is my a mode. So now I want to calculate by applying boundary condition. I want to calculate number of modes. Okay, number of modes of propagation, number of modes of propagation. Okay, so now there is no time left. I have planned for this to do today. Okay, but we have to stop now because there is other class also. So tomorrow we'll calculate the different modes of one-dimensional lattice. Okay, I hope this is clear. This is clear to you. So can I stop now here?
Okay, sir. Thank you, sir. Good night, sir.
Good night.
सर सुपर कंडक्टिविटी और क्लास होगा या
सुपर कंडक्टिविटी मैंने देखा एग्जाम के क्वेश्चंस आए नहीं है आपके, उतना आते नहीं है, तो उसमें स्टैटिकल मैकेनिक्स के अंदर जीएल थ्योरीज अलग से कराते ही हैं, ठीक है, और उसमें से एक एसी फील्ड जो सिलेबस में तो नहीं है पर मैं कराऊंगा, वो फ्री इलेक्ट्रॉन थ्योरी की बात कराऊंगा मैं, ठीक है
Excuse me, sir.
हाँ बोलिए.
Here's a suggestion. Actually, the thing is कि जो हम लोग chapters पढ़ रहे हैं, हम लोग काफी बीच से पढ़ रहे हैं. तो I was saying कि अगर हम लोग पहले से पढ़े, like पहले आप crystal structure पढ़ा रहे थे और उसके बाद ये सब चीजें सब आप बता रहे थे कि ये first brilliant zone है. तो like वो थोड़ा क्लियर सा है पहले से concepts की कौन सी चीजें.
एक्चुअली जो फर्स्ट ब्रिलियंट जोन है वो क्रिस्टल में बताते हैं, यहाँ पे भी बताया है. ओके, अभी हम जो चल रहे हैं आज की क्लास के बाद में वो पूरी ऑर्डर में है, ठीक है. एक क्रिस्टल चैप्टर है वो हम सबसे लास्ट में करेंगे, और अभी हम जो कर रहे हैं अब सारा ऑर्डर में है, क्योंकि अब हम करेंगे लैटिस वाइब्रेशन. फिर लैटिस वाइब्रेशन के बाद में वी विल गो फॉर थर्मल प्रॉपर्टी विच इज डायरेक्टली लिंक विथ योर लैटिस वाइब्रेशन. दे डोंट रिक्वायर much knowledge of your crystal structure. Okay, then you will go to the free electron theory and theory. Okay, so now we are in correct circle. Okay, that superconductivity was a small chapter. Okay, that was a small chapter because their questions are only asked on formula, so that's why I have completed that chapter first. Okay, but now it will be there except lattice crystal structure. Okay, because any chapter you know some information, some memory it require. Okay, there's no chapter is independent. Okay, there is no straight line. If I want to do, I start first here and then go here, then nothing like this. Okay, even you to go crystal structure, you need some basic information for something, some other things. Okay, so
I also have a doubt.
Somebody mic is on.
Actually, I am asking.
Sir,
here you have told that k values are the discrete one.
Yes.
But the graph we obtain is the continuous one.
It is looking like continuous. Okay. Actually, if you plot, these are discontinuous. These are discontinuous points. Now, because the number of atom is so large, our number. Okay. If you take the lattice, the number of atoms, they are very high. 10 to the power 23, 10 to the power 10 order. So this number is lattice points are so high. Okay, so these points are very close. Okay, so tomorrow I will show you the number of modes. How many modes are there between 0 to pi by a? The number of modes depend how many atoms are there in chain. Okay, or how many lattice points are there. If the lattice number is so large, okay, so these points are very close. It's look like it is continuous. Okay, but they are not continuous. Okay, wavelengths, okay, they are very nearby. Okay, so they are very close k values. And in the case of continuous medium, that become continuous. Okay, like a free particle, your k is continuous. Okay, so here k is not continuous, wave vector is not continuous. Okay, when you are talking about crystal,
for large number it seems to be continuous.
Because there is a boundary. Whenever there is a boundary, okay, you have discreteness. Like you quantum mechanics, you read your particle in box. So when you keep a particle in a box, okay, when you try to restrict that motion, then you have discrete energy levels. Okay, discrete energy levels, you have discrete lambda. Discrete lambda means your discrete k. So whenever you apply boundaries, okay, that will always restrict your motion. Okay, so here also we have crystal, but that may be also limited, na? Okay, that seems like a number of crystal large. Okay, but dimension L is limited. Okay, so for that cases you have this k values are also discrete. Okay, tomorrow we will see. Okay, so that suggestion was good. Actually, we should have started from crystal structure, but there are some other students, okay, who already completed this crystal structure part. Okay, so if somebody, if some students are facing problem, okay, if they want me to do crystal structure first, okay, I will call them separately. I finish this crystal structure first together, okay. But I don't think crystal structure required. Now whatever we are going to do, okay, like thermal properties, free electron theory, I don't think we much require the knowledge of crystal structure, okay. So whatever require, that their terms you already know, like reciprocal lattice, you already know what is reciprocal lattice. Okay, terms, inverse lattice. So terms you already know. So I don't think that much, like lattice, all of you know what is lattice. Okay, I use what here lattice. Lattice already know what is lattice. Okay, you have lattice point, imaginary points in the space where you have atoms residing. Okay, that much only information we require. Okay, not much mathematics is required of crystal structure in these chapters. Okay, I hope I gave the answer.
Sir, I also have a doubt that what kind of question is asked? Basically, it's conceptual or it's formulated.
See, that depends, that chapter to chapter. Okay, the most important, like superconductivity, they have just formulas. Okay, many questions they are asked formulas and what are the facts what we return. Okay, now if you come here, okay, they ask question or dispersion relation, just like we have calculated a omega value, so they'll ask what is phase velocity, what is group velocity. Okay, now tomorrow we'll see we'll calculate number of modes, density, they'll ask density of states. Okay, so in solid, the important topics are density of states, okay, which we'll start maybe tomorrow or day after tomorrow. Density of state is the most important topic in solid physics. So many questions are asked density of state, and then once you know density of state 1D, 2D, 3D, 0D, then they ask question from semiconductors. Semiconductor also important chapter. So the one semiconductor, second band theory, and third is crystal structure. Okay, these are the three important topics you should have command. Most of the questions are asked these questions. Like these chapters, they are small chapters. Okay, and you study this chapter in statical mechanics also, like specific heat. Those there is an overlap. So in solid state, you should command crystal structure, then semiconductor, and then density of state. That means free electron theory and band theory. Okay. So
Yes, sir.
please look previous year papers also. Start looking previous year questions. Okay. I have given one test also, so probably it will reach to you tomorrow night. Okay, and then I will give every chapter. I will give at least one or at least one or maximum 2 or 3 this test for each unit. Okay, so that you should know what you are reading.
Okay, sir. Thank you, sir.